Hello and welcome. Welcome to the second session of our January WARE series on circularity. There's a few hundred of you that have registered, so just going to give it a couple minutes. And while you're filing in, as per usual, if you're a repeat attendee from one of our sessions, we just love hearing where you're coming from today. So if in the chat function, you don't mind just mentioning what city or country you're coming from, that would be wonderful. Brooklyn, New York, hello. Don't be shy. Montreal, Luxembourg, Italy, the UK, California, Estonia. Welcome to all of you. Toronto, of course. South Carolina, Georgia, Scotland, India, the UK again. What's ATX? Anybody know what ATX is? California Bay Area, Colorado, Texas, Vancouver, London, Madrid. Amazing. Hello, everybody. So glad you could join us. If this is going to be like anything like the last session, which I'm sure it will, we need to be on time here. So I'm going to just kind of jump in while everybody's filing in. I'm Kelly Drennan, the founder of Fashion Takes Action, which is Canada's only nonprofit organization devoted to advancing sustainability across the entire fashion system since 2007. So that means we work with industry and consumers. And before we begin, I'd like to share a land acknowledgement, which is really important for us at Fashion Takes Action. We do have quite a global audience here again with us, and I am joining in from Toronto, which is the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples, and is now home to many diverse First Nations, Inuit, and Métis peoples. Toronto is built on sacred land that is part of an agreement between Indigenous peoples and allied nations to peacefully and respectfully care for it. The reason I share this acknowledgement is because it is evident that the colonial structures used to once settle this land are the very same systems that support the exploitation of resources and people in the global fashion industry today. FTA is working to help dismantle these colonial structures by providing platforms like WARE. We aim to give a voice to the people who are being exploited, to showcase the importance of circularity in fashion today, and to acknowledge the need to prioritize respect for the land and people involved. This monthly webinar series is free. As a nonprofit, that means we rely on sponsorship and donations. We are currently trying to raise $25,000 to digitize our youth education program, My Clothes, My World, which the fundraiser ends at the end of this month. So as a thank you to us for bringing you this amazing content each and every month for free, we ask that you please consider making a donation today, even if it is just $5. There's over 1,000 of you registered today between the 3 sessions, so $5 times 1,000 could go a really long way to helping us. I'm really excited about this panel on garment-to-garment recycling innovation. It's a topic that I have spent a great deal of time researching, and I've known all of our guests for years, so I'm excited to have them all together on one panel. Oftentimes you see our recyclers on a panel with others who have maybe a different perspective or take on circularity, and so it usually means there isn't enough time to really dig into the details, and that can leave people feeling a bit confused, myself included. So I'm happy to say that this next hour, we're going to really nerd out on the topic of textile recycling. And it's going to be led by my colleague, Sabine Weber from Seneca College. Sabine and I have actually worked together for many years in an effort to divert textiles from landfill, working with NGOs, municipalities, collectors, and retailers, and also looking to unlock the many solutions available for reuse and recycling. Sabine has done her master's in textile waste. She's written numerous reports and papers on the topic, and I'm actually excited to announce that together we have a report coming out very soon on post-consumer textile waste data in Canada. So look for that. We're currently together conducting a textile recycling feasibility study, which is thanks to the support of Environment and Climate Change Canada, our federal government. And that will result in a roadmap for the industry with recommendations for policymakers to hopefully affect some much needed change on the policy level. So without further ado, I'm going to hand it over now to you, Sabine, and I'm going to turn off my camera and let's get started.
Thank you, Kelly, for this great introduction. I don't want to lose any time and I just want to jump into your presentations. Cindy, would you like to start first?
I would be delighted.
And then maybe we follow with Stacy from Avenue and Luke from the Circle. So I'm just saying Cindy is presenting one again, and I just want to give you the word. Thank you.
Thanks so much, Sabine. Let me see if I can get this up on my screen. How is that? Can you see the first
Perfect.
slide?
Yes.
It's a very good start. Well, thanks for that introduction to both of you, for the acknowledgement at the beginning there, Kelly, and also for having us on the panel today. I mean, it's nerding out. It's my idea of fun. So I'm looking forward to diving into detail. I'm gonna just breeze through a couple of slides here to be able to give the others a bit of time and also for us to dive into conversation, because I think that's where it gets very interesting. But just to provide a bit of context, this is a simple overview of our process that we've developed for regenerative recycling. If you start on the left here with the inputs, we can take in pure polyester, polycotton, and polycellulosic blends. They get entered into our process. And then if you imagine a big washing machine with multiple cycles, we're able to carry out a number of steps. So we're able to separate, decontaminate, and extract the raw materials we're after using a solvent-based dissolution approach. So it just means we're dissolving those raw materials to be able to recapture them. We're also able to filter out all the dyes, the finishes, the TiO2, the antimony. All of this comes out of as waste. So the more polyester, cotton, and cellulose that goes in at the beginning, the higher the yield that we have. And then our end products are a PET resin or a pellet that can go back into fiber spinning, the same sort of chemical structure as virgin PET. And from cotton, we're able to dissolve that and recapture the cellulose, again, to go back into fiber spinning. Now we have 3 goals with our technology: that the outputs are virgin equivalent, that they're cost competitive, and that the process itself is environmentally friendly. And so far, we're on track with all 3 of these goals. To give you an example or two, the solvent system is closed loop, so they get recycled again and again with minimal loss, less than 1%. Another key distinction with our technology is that we are, rather than some of the other technologies that are breaking down polyester down to their monomers or their building blocks, we're simply recapturing the polymer and building it back up to a virgin equivalent polyester. So what that means is that it's less processing steps, less energy, and lower costs. And then quickly here, I think we're going to get into it on the questions and answers, but just an overview here of our feedstock specification. So we've been working for years and continue to do so with the end-of-use textile supply chain, all the collectors, the sorters who are out there collecting all of our end-of-use textiles, sorting them into rewearables and non-rewearables. We're after the non-rewearables. Anything that can't be reused, we'll take it if it's pure polyester, polycotton, polycellulosics, and it can have up to 10% other. So that can be nylon, wool, other materials. It doesn't disrupt our process, it just affects the yield. So the more poly, cotton, and cellulose that's in there, the higher our yields and the better the economics. We want the materials to be dry with no mold or contamination like oil or paint. And then when we get to market, we're also going to require a pre-processing step where textiles are chopped up, the buttons, the zips, all of the accessories are removed before then going into our process. But one of the exciting things about what's happening in the industry is that we're now starting, or brands are starting to design for circularity, for recyclability, excuse me, which means that all of those accessories and trim and extra parts going forward, as long as they're made from recyclable materials that we can recapture, polyester, for instance, in the case of zippers, then those could go straight into the process, and we could cut that pre-processing step out altogether. And then finally here, just to give you a sense of where we're at in development. So we've launched our pilot plant, which you can see here in Redcar in the north of England in 2020. And the purpose of the pilot plant is we're carrying out multiple trials, optimizing each of the processing steps to inform the next stage of developments, which is our demonstration plant and the demonstration plant design. And that will be designed. Following that, we're creating our business model is based on a global licensing plan. So as soon as the demo plant is complete, up and ready, then that will provide the blueprint for licensing the technology around the world. And then along the bottom here, you can see some of the brands and companies on board as pioneer members. All of these companies have access to our developments and more importantly, preferential access to our first industrial outputs. I'm going on longer than I intended here, but hopefully it's useful for the dialogue. And finally, just to end on this slide, I wanted to flag up FiberSort here in the Netherlands, one of a couple of fiber sorting technologies in development, which is absolutely crucial for all of us. We need this evolution in the end-of-use textile supply chain to happen so that we can build our plants close to the source of collection, and for all the non-rewearable textile segments, they can be sorted by fiber to our specification in a highly mechanized way. So cutting out some of those labor costs to enable the economics of feedstock to work for our future plants. And on that note, I will end and hand it over to Stacy.
Thanks, Cindy. I will start my video. Can you guys see my screen?
Yes.
Okay, great. Okay, so jumping right in, Evernew is an R&D company. One of the things that I just want to clarify is we don't make or sell fiber, fabric, or garments. We own several labs and pilot lines in the United States to rapid prototype new concepts for brands and retailers and producers who want to open new markets. We own IP, and I'll take you through the IP that we own, and we distribute that to our partners. And we also own a consumer-facing brand called New Cycle. New Cycle is an umbrella brand, and to a consumer, it shouldn't, if it says New Cycle, consumers should understand it's made from their old things and it's recyclable. So I'll take you through our first launch test, which is happening this year. In 2021, we're specifically bringing lyocell made from cotton waste to market. So we're partnering up with waste owners to train them to sort, separate, and grade textile waste. We are training paper pulping mills to make pulp out of cotton waste instead of timber. That then goes into fiber producers that currently make fiber from trees. And then from there, the brands and retailers pick it up in their supply chains, and we're bringing the textiles or the technology to consumers and working with brands and retailers to make sure that their consumers understand what the product is, why it was made for them the way it is, and ultimately how to recycle it when they're done with it. So this is a test of the New Cycle process in 2021. In terms of our total technology pipeline, we've got regenerative cotton technologies, and this is using the existing solvents. So for Cupro, lyocell, modal, and viscose, We also have next gen solvent systems that have not been commercially commercialized, that are designed specifically for post-consumer waste. Those are a little further down the road because they do require capital equipment investment. We can also break down polyester. We can break down any blend in our lab, and we're also breaking down and creating a recoverable stretch product. So in the future, all textiles, all garments should be recoverable and recyclable in the future. We're starting with one technology in 2021, and then we'll be evolving our portfolio as we head into 2022. And just to end, this is a photograph of the launch product that we put together with Adidas and Stella McCartney. This is made from lyocell and cotton, and the garment is fully recyclable. So I'm looking forward to answering any questions and hopefully giving you guys all access to New Cycle as we head into 2021. Thank you.
Thank you very much. I'm Luke Henning, the CFO of Circ, and I'm going to keep mine nice and brief. I think the others have given a very good explanation of the types of processes and things that we're talking about. What we do is we look at poly-cotton blends as our primary focus. So we're completely blend agnostic, so we can take from 100% polyester all the way through to 100% cotton. And what we do is we actually depolymerize, we break down the polyester into its basic building blocks so it can be made into new polyester. And then the cotton is recovered and turned into a cellulose pulp, which then can go, as mentioned, into lyocell, into viscose, into cupro, into modal. So here, just for illustration purposes, is the same t-shirt on the left and the right. And that was an 80-20 blend. So after it's gone through that depolymerization step, after we've broken down that polyester, you'll see the residual cotton there. It comes out, the dyes, the finishing chemistries all come off there. The threads, which were polyester, have all dissolved, so it's pinned back together. And then that cotton is the portion that goes back into making cellulose, and that cellulose replaces trees because currently it is a tree-based fiber that is lyocell and viscose. So this replaces trees as a drop-in replacement, and then the polyester monomers can go back into being made into PET chip, and we've made that into polyester fiber and yarn. And then the finishing chemistry and the dyes can be responsibly collected and discarded. At this point, they cannot be reused, and that is our waste stream at the moment. So as I say, that's the exact same t-shirt, left and right, before and after our process. Thank you.
Okay. I think, Kelly, can you take me back? Kelly?
Lost our host.
Yeah, I'm here. You just have to hit start video on the bottom left.
I can't start it. I cannot start it because you stopped it.
Okay, hang on. That work?
Okay, yeah, I think now I'm back. Well, thank you so much. This was really great. And I just want to make sure I got everything correct. So at the moment, you all use different feedstocks. So Luke, you're working on the poly cotton. Stacy, at the moment, you're mainly on the cotton products, I want to say, but the future is also extending the business model to poly cottons or polyester, correct?
All fibers.
All fibers. And Cindy, you are specialized in the pure synthetics, in polyester, polyester nylons as the main feedstock. And
we're doing poly cotton as well. So polyester cotton blends, kind of the highest proportion of what's out there.
Okay, and you already said your material can be somehow contaminated like 10%, but it would not affect the process, but you would have less to harvest. How is this in your case, Stacy, with Avenue? What is in your, how is the problem with the contamination? What happens if there is something, you know, a fiber inside which shouldn't be there?
Yeah, that's a great question. So we start by mechanically sorting, separating, and grading. Cindy showed the fiber sort technology. We own a technology that's similar to that. And we basically start by sorting, separating, and grading the textile waste to make sure that we understand what the fiber content is. So essentially, you set the machine to pick up anything that's 95% cotton or above. And anything that is not 95% cotton gets blown into a different bin, essentially. So we can do a really good job of isolating 95% cotton or higher. And we process about 5 to 10% contaminants. We try to keep contaminants around 5% to start, and then we'll be layering on complexity as we move forward.
So quite often we have like this 98% cotton and then 2% some kind of lycra or elastin. I think this is such a common blend. So this would not be a problem in your process. Is this correct?
No, usually it's generally if you have cotton, there's polyester involved. We're separating out the stretch polymers. We're not bringing stretch into the system initially, but we anticipate there's going to be about 5% polyester, which we flush out.
Okay. And Luke, how is it with you if there is some wool inside in the blend? It somehow, you know, could be theoretically.
So
Would this be a problem or what would happen?
The predominant contaminant there is, as you mentioned, the stretch. And there, you know, with those sorts of small blend ratios, it's more just that we're not recovering it. We can process it through our process, but then it comes out as a waste stream. So we're not currently recovering the elastane. So what happens is the elastane then would be extracted, and it's a relatively simple extraction from our process, but it's it definitely affects the economics, to Cindy's point, because it just means you're recovering less material, and additionally you have additional waste, and it clogs filters and things like that. So
how can I imagine this? Will this kind of, you know, materials end up in the same pot where all the dyes end up? You know, those materials which you can't process, will they go where the dyes go? Or?
So for us, the dyes are still the dyes, and a lot of that chemistry is in the liquid stream, and so you would actually take it off before then. So when separating out the liquid from the solids, you would take out the elastane at the same time, and then the rest of the liquids, most of those are dissolved in the dyes and the finishing chemistry, and so that gets processed out.
Are there any problems, I don't know, in general with those dyes, Stacy or Cindy, you know, where you don't know what to do with them? Are they difficult to get rid of? Or is there a difference if you have azo dyes or natural dyes, or doesn't this matter?
Dye management is really important. Right now, we're basically doing exactly what Luke is doing, where we have to separate it out, and then it's considered waste in our supply in our system.
Same with us, and it's dyes can be different in polyesters or synthetics as they are with natural. So it's a different approach to the dye removal on both of those. But yeah, essentially it's a waste material for us. I mean, we have done some trials with other companies who are able to then take the dyes and reuse them. The question, or reuse them as black, or, you know, over dyeing. The question will be whether it's economically viable, you know, at scale. So, you know, of course, I'm sure the others are looking at valorizing as much as possible from our processes, from the systems, and it will come down to the economics at scale, really.
And Okay, one dyes is of course one chemical treatment, but what is with others? We in Canada have a lot of flame resistant treatment, which I wasn't even aware of. And of course there's static treatment. There's so many different treatments in those fabrics. What is happening with those? Is
So
this like the
form,
dyes?
those are like the dyes. They form part of the waste stream. The key thing there is making sure that they're disposed of responsibly, because the big thing here is that some of the chemistry used in these finishing chemicals and in these dyes, you know, they're less than stellar themselves for the environment. Now, the thing is, those would be naturally bleeding into the environment anyway from the landfills. And so the benefit here is you're actually able to capture them, concentrate it, and dispose of it responsibly.
Okay, cool. Good. I didn't know. I wasn't aware that this is so easy to manage. It sounds easy. Maybe it's not.
It sounds easy.
Because you've solved it already. Okay, good. So one more thing. So you all have your different feedstocks and you're all kind of solvent the material into some kind of a pulp. Is this correct?
So let me just be clear. We may use some of the same feedstocks, but there's a point here in that there's a mountain of this stuff out there. It's not like this is a problem. You know, if we all used exactly the same feedstock, we could easily, you know, continue happily processing and not need to view ourselves, you know, in a particularly competitive way. The other thing there is, yes, anyone who's most of the cellulosic processes are coming up with pulp as the cellulosic output.
Okay. So is it the same for you, Cindy? Would you say you also have a pulp in the end? Two different kind of pulp buckets? I want to say the one where you have the polyester.
Exactly.
The one, yeah. Okay. So Stacy, you always emphasize you are not a fiber mill. You are a technology company, and you want to sell the technology to other fiber mills in the world. How is this with Circle or with One Again? How do you see yourself? Cindy, you want to start on this one?
Yeah, I touched on it in the presentation, but our business model is based on selling the technology to plant operators around the world. And as soon as our licensing package is completed. But obviously, you know, this is about, you know, we all play a role in the entire circular system, and all of those bits need to be joined up and connected. So it really is about connecting our licensees with the feedstock collectors, the end of use textile supply chain, the post-industrial textile manufacturing world, the brands, the retailers that drive the market, the supply chains. I mean, it's sort of, you know, we know where our role is, but for it to be successful and for our plant operators to be successful, we need it to all be linked up, as well as with the additional layer of policy and legislation that can really drive forward some of these issues around collection of textiles, banning textiles from landfill, that sort of thing. In Europe, we're far ahead with things like that. And I think in the US, there's a bit to catch up on, but needless to say, when the Americans put their mind to it, things can happen pretty quickly. So yeah, it's a complicated space, but very interesting. And I think a lot will shift as soon as we get some of these technologies actually to market.
So where does your technology end, Cindy, when you have this pulp produced or when there is the fiber produced? Where's the end of your technology? In the fiber?
So our outputs, we have two outputs. One is the pulp on the cellulose side, and one is a polyester pellet or a resin. Both of those will then get sold on to fiber spinners.
Okay, now I get it. So you're not producing a fiber, because Stacy, I think you are producing really a fiber, and I think you've been working on a new generated fiber type.
Well, we have pulp formulations for all of the existing solvent systems. So for lyocell, cupro, acetate, and rayon. So those are the existing man-made cellulosic solvents that are out there. Rayon and acetate are not recyclable back into garments. We can turn those into corrugated cardboard and packaging, things like that. That's why we're using lyocell and cupro to start for our new cycle brand, because we can recycle those back into on par with virgin like quality. So that's based on the existing solvents for fiber production. We also have new solvents that have been designed specifically for garment waste. All of the solvents that exist for man-made cellulosics have all been designed for trees, for wood pulp. So we've retrofitted our technology to fit it into something that was originally designed for trees. The next generation solvents are designed for waste, garment waste. So they're much more robust. They have better chemical recycling. They're not precious when it comes to managing dyes, finishes, blends, things like that. But those are quite a few years out, because it does require a CapEx investment.
So you said you're working with cupro and tencel. This means you're working also with
lyocell.
And
we're not working with tencel. We're working with lyocell. Lyocell is a generic fiber.
Okay.
Yeah. Tencel is a branded
it's sometimes
fiber.
tough with seeing the generic fiber types,
Yes.
the different ones, and actually
Yes.
the names and the companies behind each fiber. And sometimes I have the feeling maybe one day we have so many new generic regenerated fiber types.
Yeah.
And I'm kind of afraid that we as customers maybe don't even know, who is behind that and what is it?
Well, it's ripe for platform disruption, because there are only 18 generic fibers on the planet. And 90% of the market comes from 2.
Clear. You want to say them?
Cotton and polyester. Yeah. Yes. So it's ripe for innovation here. And I think, the future is for every virgin material, there will be a regenerated counterpart for that. It's not about replacing anything. It's about intelligent design and reusing as much as what we already have.
Okay, cool. So let's talk a bit more about this contamination and the cleaning process and the pre-sorting. So once you imagine, I think right now you're probably all working more with offcuts and pre-consumer textiles, which haven't been contaminated by the people, and where you don't have to deal with separating the garment, into single pieces and getting, or is it wrong? Are you already all working on the garment level and post-consumer? Or is it more on the pre-consumer at the moment?
I would say that we've been able to show successful repolymerization and new fibers from both post-consumer and pre-consumer fabrics, basically. So we talk about post-industrial, pre-consumer, post-consumer as the 3 main segments, and we've done all 3. And I think that's probably the same for both Stacy and Cindy.
Cool. Okay, now I have another question. When you actually recycle the material and we want to produce a new fiber, do we need also virgin materials to make those new generated fibers? I know that we can even recycle cotton mechanically, but then we need a lot of cotton also in virgin material to get a high quality material. Does your processes require any virgin materials?
Our process does not require virgin materials. However, in order to get into a cost competitive range, we are cutting our material with virgin, because virgin materials are much less expensive. So it really comes down to cost and recyclability. So we blend our new cycle fiber with lyocell fiber with cotton, because it's easy for us to recycle that back again. But we could make 100% new cycle product. It just would be cost prohibitive.
Wow. That is crazy. This is
Well-
really shocking me that you have to mix it in order to make it financially more interesting or more compatible. That is shocking.
Sabine, this is not, this actually, people are surprised by this, but if you think about it, all the major recycling industries that we've developed have followed the same model. You know, whether you talk about paper or plastics or aluminium, all of them followed this model where they started off with a blend ratio and then moved up to 100%. And it was largely due to bringing, you know, as the technology iterated and became more and more efficient, and as it reached those large economies of scale, you got the price point down to the level where it could compete with virgin. Now, so this is actually a very natural cycle in the evolution of recycling technologies. So people think about it like this, but they forget that, you know, paper used to only be blended, you know, 5%, then 10%, then 20%, then 50%. Now we're at 100% recycled with a lot of paper products. But this was not the way, you know,
You don't
you
start
go back
there.
20, 25 years.
Yeah, and I think that that's the difference between regenerative recycling and mechanical recycling, is that the quality is there. So you don't have to blend it for quality reasons. Whether you need to do it for cost is, you know, another question. I mean, I think Luke's point is really well set out in terms of how the market dynamics work. And, you know, the way we can get this type of technology to market, you know, sooner and faster is, you know, aiming, our goal from the very beginning has been to have a low cost process, so that once you scale that process, you have your plant operators have more flexibility to buy feedstock, end of use textiles at a reasonable price, because that whole market's going to change quite dramatically too, as more of us get closer to market and start buying up. Luckily, we've got RenewCell already out there proving volume. And, you know, that's a great indication to say that this is coming. So I think there's going to be a lot of, I don't know if instability is the right word, but evolution of the market as we progress over the next couple of years. But eventually, our target 100% is for scaled outputs and volumes to be able to compete with virgin raw materials, so that there is no choice. There is no sustainability tax or premium where, you know, it keeps brands in a corner where they can only afford or aim for, you know, proportion of collections to be made from recycled. So if our goal is 100% circular, we all have to be working together to getting to that cost model.
So the challenge right now is to be producing a product which is really pricing compatible. But isn't there also a bigger problem of, you know, who is financing this whole investments in your technologies? Actually, I mean, everybody in the fashion industry would like to be circular, and everybody wants to be sustainable. But who can actually, or who is financing this part? And I think, you know, a brand owner is not necessarily the person who owns the fiber mill. So how is this whole technology now being financed from investors? Or maybe you can talk a bit about those issues about financing your technology. Who wants to start? I don't know.
You know what, as the CFO, let me jump on this one.
I know your financing background, and I just saw the financing round of 8 million, which seems to be a lot of money. But then I thought maybe not, you know.
Well, I think it was, I'm trying to think how many billions or trillions McKinsey said this was going to take to transform the fashion industry. But the point here is that at this scale, most of the regenerative fiber recycling companies are still working very much with what we would consider at-risk capital, which is venture capital. So this is either venture capital that is funds that are can see the market opportunity and are looking to invest in the space early. They're comfortable with the risk, and they want to get in early so that they can make the outsized returns. And there are some brands that are playing in this space. I mean, there were some definite leaders from the brands in the space. If you think about H&M, which was a big market leader. I mean, we took our lead investment from Patagonia. So there are brands that have some form of investment vehicle that are putting money into the space. Some of the supply chain partners are starting to play more actively in that space. And, there are strategics who are investing. So these are either engineering companies or waste management companies or supply chain partners. I use again our example of we took investment from Marubeni, which is a large Japanese consortium that does finished garments as well. But, what we've seen with RenewCell is that once you make that shift to the public markets, there is definitely more than enough appetite out there for people who are looking to invest in these solutions.
Okay.
And there's a lot of ESG funds who are looking for solutions that have reached that public market stage. I mean, RenewCell listed at, I think, around 100 Swedish krona, and they're trading at about 280 Swedish krona now, less than 2 months later. So, their share price has tripled because of the demand.
Okay.
I think there's a lot of interest, but I think as well, if you're talking to the people, in this room, I use room metaphorically here in COVID speak, but we're all looking to partner with larger companies, either through licensing or through joint venture, to accelerate that because they've got existing assets, which substantially brings down the cost of transforming this industry.
So the recipe is partnership to find customers who are buying the material, partnerships who are helping to financing it. So it's partnership and investors, the recipe here to success. Okay. Stacy.
Yeah, I've always been afraid of strategic investors. We are considering strategic investors now, but one of the hard parts about strategics are, if a strategic puts money into your company, would their competitors ever use your technology? That's really the biggest fear that I have around taking money from strategic partners, because the spirit of what we're doing in the world transcends just one company's usage, or so it really does have to be the right partner when it comes to strategic financing. I think now that we're ready to start thinking about scaling, we're looking at strategic supply chain partners. These are folks that already operate in 30 plus countries who can help us fast track the scaling. That's really attractive to us. But, you have to pick your partners when you take money from investors. You have to pick your partners really well. One of the sayings is you can never fire capital. So, if you've got one partner, if you've taken money from one investor who you find out is not in alignment with your strategy or your vision, it could completely sink your company. So taking money is not easy. It's more of an art than a science. And, we've got incredible investors who have been really supportive, but they're not easy to find. I think hopefully the people who are coming behind us will have an easier time after we've all proven that we're commercially viable, commercially successful. And then we'll start seeing more capital come into this space because we do desperately need it.
So we have a bit of a different approach between Avenue here and Cirque. What is it with you, Cindy, and Juan again? What is your approach?
Yeah, well, actually, to respond to Stacy's point there around strategics, I mean, we had a slightly different experience in that our early stage large scale investor was H&M, and their position was absolutely the opposite. They welcomed in as many other brands or companies or supply chain producers as possible because they knew the more money, the quicker we get to market, the bigger it is, the sooner they're going to get the outputs at a price that they're happy with. So, but it does give out a message to, yeah, it is an unusual space for brands to get into bed with their competitors from an investor perspective. But I mean, H&M was just one of many. We have two supply chain companies from Mexico. We have a chemical engineering company, Sulzer Chemtech from Switzerland. Our approach was to go out and find the companies that will benefit from seeing this get to market, bringing them around the table and making it happen. I think that with a mix of VC money is good, but for us, we've gone with strategic investors. I think this has been the most difficult time for all of us during the R&D phases, during the scaling phases. It is like pulling teeth trying to raise money for this stuff. But I think, don't worry, anyone who wants to invest in the future, the next phase of investment is going to be on the rollout of this stuff. I mean, we're going to need to build plants for decades to replace the use of virgin raw materials. So any investor community out there wanting to put money into it, get ready, because it's coming and it'll be the next phase of
decades. Oh my God. Well, I will see this at the end of my life. I want to see it now.
It will happen. But I think when we get to kind of fully circular, when we've replaced the use of all virgin materials to go into textiles, where it's 100% textile to textile, it's not going to happen overnight. I mean, the numbers, I think everyone's got different numbers, but we use around 86 million for polyester and cotton going into textiles. You know, you break that down into numbers of plants, it's going to take a while to transition.
One really short question before we have to start with the answers and all the questions from the Q&A, because we have quite a lot. One, how often can we recycle the material with your technology, Cindy?
On the polyester, it's again and again and again. You can rebuild polyester to be virgin equivalent quality because it's man-made. Cellulose is different. It will break down over time, but if you look at it as a kind of global pool of textiles, it will again take decades before that cellulose breaks down. So you can use that again and again and again.
I know, Stacy, one time you said your material can be recycled 6 times and then it falls apart in sugar. This is how you explained it to me.
Yeah, basically the cellulosic chain with cotton starts out very long. And every time we break down the cotton using the lyocell method or the Cupro method, we lose about 10% of that cellulosic chain. So we've tested 5-6 times and we're still not to the sugar stage. So we know that we can basically regenerate our own fiber 5 to 6 times or more. But, you know, to Cindy's point, this is going to be, I mean, if you think about it, that is decades.
Yeah. Okay, so let's have a look at the questions from our audience. And the first question here comes from Pradip Matani. And she asked, what are the limitations in scale and how do we calculate the positive on the environment? So I think that's a really interesting part. How can we actually measure the benefit for the environment with the technology? So who wants to start on this one?
Simple answer for us is by preventing textiles from entering landfills. That is where we get the biggest impact reduction. So that's what we're focusing on, making sure that everything we build can come back into the system, because that's really the greatest intervention point. Right now in the US anyway, over 17 million tons of textiles are entering waste streams. So by keeping them in circulation longer, that's where we get the biggest impact reduction.
Okay. And anybody else, how you're measuring the benefit?
Go ahead, Luke.
I was going to say, so we, you know, I think this is probably the same for all of us, is that we've done preliminary life cycle assessments but to a large degree, they're directional. That measures your reduction in greenhouse gases versus virgin materials. But, you know, until you are fully operating at these large scales, you will not have a truly accurate measure. But I think for all of us, the indication is very clearly there. How much better it's going to be, will be finally sorted when we're at scale, but it's very clear that we will all be substantially better than virgin in terms of greenhouse gas emissions. And that's in large part due to the fact that we are recovering waste that is damaging to the environment in and of itself.
And replacing the use of virgin production, which takes up vast amounts of energy, land, pesticides, and that sort of
And
thing.
water.
I think, yeah, and water. And just
sorry.
to finish that point on LCAs and life cycle analysis, ultimately, they don't actually compute until you have your industrial scale process up and running. So we can do, as Luke was saying, preliminary versions of it now, but ultimately we need to do it once we're up and running, and we can really make those measurements around those different variables with more accuracy.
The one point I would make here, and this is a key one, which a lot of people don't consider, is that by reusing and recovering polyester, you're not getting fresh polyester from oil, which means that the oil is a natural sequestration of carbon underground. So the problem with extracting oil is you're bringing that carbon above ground, and then you're adding it into the cycle that's above ground. And that's where it's such a problem for greenhouse gas emissions.
Good, thank you. I think we answered this question. And the next one, which I thought, which has just been disappeared from my line, aren't microplastic an issue with polyester fabric and fibers, and how do you address this? And this question comes from Chris Moken. The microplastic issue with polyester fabrics. Anybody can take on this question? What is going on if we wash those, let's be clear, we wash those reclaimed polyester fibers, will they cause more microplastics, or how is this an issue?
Here's the thing, the polyester, that issue will ultimately be solved not really by us, but, and I'm sorry if I'm speaking for the others, but more once you're able to produce additional fibers that don't actually shed in this way, or there are some interesting technologies around capturing and trying to stop that pollution with things like electrostatic filters and capturing systems that people are putting in place. Polyester is not going to go away as a fiber. It's too prevalent in its use yet. So we can't just design out polyester at this stage. So it's very important for us to be able to at least recover it. But will we ultimately be influencing the micro shedding and the microparticles issue? I'm not sure that we can say that we can.
Okay, so it will remain a problem. Yeah.
Well,
Yeah, it's a yarn spinning issue, really. I mean, the yarn spinning technologies need to be developed to minimize shedding first, and it's a very layered, complex problem. It has to do with fiber, yarn, and fabric finishing. All of that contributes to shedding and the natural wash and wear cycle. So it's a bigger issue than just on the fiber side.
and polyester isn't the only microfiber found out there. Cotton, cellulose, they all have dyes in them, which gets released into the environment. So it's a much bigger issue that needs to be tackled from multiple angles.
Okay, so maybe one more thing to answer this question with the environmental problems. What happens with those chemicals? This was a concern here as well from the audience. What happens with those chemicals which you have taken off from the garments? How you manage those? I mean, right now in a lab, it's probably not much, but if I see this in scale, you might have tons and tons of material of, I don't know, is it liquid or is it solid? I don't even know that.
Well, one of the things here is those chemicals are there anyway. We are not adding to the chemistry. The difference is here we're able to capture it and concentrate it.
I know.
Yeah, and I think with any industrial process, you will have waste. But what we are doing is cleaning out what's been put in the first place. And there are responsible ways for disposing of that at industrial scale. But ultimately, you know, we want to see the industry starting to clean up what's going in at the beginning so that there's less and less waste when it comes to us. And I think that's already, I know that's already starting to happen with different brands and different supply chains looking at those materials. So I think over the coming years, we're going to see a lot of change on that front, but we're never going to fully get rid of that waste from our process, but we can try and find more responsible ways of doing things with it. And hopefully, ultimately circular solutions where it can feed into another system. At the moment, it would be too costly to separate everything from everything else to get a pure substance back.
So one more question, really short. What's going on in terms of recycling spandex or all those elastic materials? This is Amy from Rowan who wants to know something. Is anybody working on those?
We are, yeah, we're working on stretch polymers. You know, we are working on a recoverable, recyclable stretch polymer, something that's easy to separate out. Right now, spandex in its current form is very challenging and costly to separate out. And Luke had mentioned earlier that, you know, if these polymers get into your spinnerets or extruders, they can clog holes and bring the entire industrial operation down. So separating out those elastomer fibers is really critical. What we want to do is try to find solutions that allow consumers to have access to stretch and recovery, but do it in ways that are compatible with chemical recycling.
So then is a question here, could we also recycle cotton hemp? But I think, Stacy, because you're working on cellulosic, it doesn't really matter if it's cotton or hemp. It's the same base, right? So of course we could do that.
Yeah, hemp is a completely different fiber. We are not currently breaking down hemp. It is cellulose, but it's not the same kind of cellulose that cotton is. So, you know, we have looked at hemp. It's not on our charter right now because we do need to go through, it's the redding process that needs to be addressed. So in the future, we may take that on with partners that aren't that R&D or that innovation.
Okay, thank you for this question, Lynn. And then I have one more question, really short. Where do you sell fibers to brands, and how can I purchase those fibers? And I think that's the question which always comes from the audience. Everybody would like to support you. And how can we do this? And where can we buy those recycled or regenerated fibers as smaller brands, not only as being the H&Ms and, you know, the big ones? Can anybody?
I would say don't knock the H&Ms because actually, to be fair, and I keep saying this, H&M has done a lot for this space.
Yes, they have.
But there are, I think, you know, most of us are, well, we're working with some brand partners and, you know, there'll be some stuff announced later this year, throughout the year. But, you know, we're not public with those yet.
Okay.
I think, yeah, before these technologies are properly industrial and producing capacity, you know, high volumes, it's going to be a while before smaller brands can get a hold of the materials. But, you know, get involved, get in touch, and let's keep talking. We're just as eager as others to get this stuff to market.
I can see Kelly is coming, so she will almost you have to wrap up. So one final question. I would like to see, what do you think? When can we see it on scale? When can we see this textile recycling on scale? Maybe as my last question. Will it be in my life?
Yes.
Yes.
You're optimistic, Cindy.
Yeah.
You don't know how old I am.
Awesome. Oh, thank you so much, guys. I mean, honestly, we just could keep going and going, and there was like 25 more questions in the chat or in the Q&A. So so big thank you to the four of you for leading this conversation. And to all of you who attended, feel free, I'm going to just put my email address in the chat. And if you want to address any of the questions that we weren't able to get to, please do send them to me and I'll do my best to answer and perhaps put you in touch with one of our speakers today. So again, thank you to Stacy, Luke, Sabine, Cindy for joining us from all the various time zones. For all of you out there, if any of you are interested in attending the third session today, which is going to look at retail models such as rental, repair, and resale, as well as the role of reverse logistics in dealing with a lot of this excess inventory, damaged out products and returned goods, please do come back at 1 o'clock. You do need to register separately for that. If you haven't already, I've just shared the link to register for that in the Zoom. So once again, thank you all. And yeah, we look forward to continuing these conversations.
Thank you
Kelly.
all.
Thank you, Sabine.
Take care.
Thanks,
Thank
everyone.
It
you.
was my pleasure.
Yes, thank
Joining
you.
audience.
Bye.
Take care.
Bye-bye.
Hi, everyone.
Bye-bye.